Let's talk about animating in Unreal. So in the previous episodes, I did some poses by just dragging bones around. That's this over here. And it's not great because I was manually dragging the bones around and I was talking about how it's pretty rough. It's not a good way to do it. Most people create their animations in Blender or Maya or something. Even if you're doing mocap, you'll clean it up in a third-party piece of software before putting it into Unreal. But there are ways to create animations in Unreal, and that's what I've done here. This animation is an idle that I put together here in Unreal using a plugin called Control Rig. It's a free plugin that you already have. You just have to turn it on. If you've never turned it on, just go into Plugins and turn on Control Rig, and you'll be able to create something like this. This allows you to really quickly put together whatever sort of animations you want in the level sequencer, which is down here. Now, I'm not saving the changes I'm making right now because I'm just doing random stuff for fun, but you can see how easy it is to, make this character do whatever we want her to do today. No problem. There are a lot of reasons why you might want to stay in Unreal to do your animations, at least partially. One reason is you might not know anything about Blender or Maya or whatever, and you don't want to have to learn Unreal and Blender. Each one is plenty hard on its own. In that case, it would make sense to try and constrain yourself mostly to Unreal. Similarly, if you are taking animations in from an Unreal library, you may want to just tweak those animations, and you can use a control rig to do that as well. I'm not going to teach you how to do that part, but that's not very difficult. You can look it up. You just have to do a few more nodes than we're going to show you today. I think that control rigs are great, but I can't find very many good tutorials about how to set them up. I've only found a couple of tutorials, maybe my Google Foo is weak, but all of them were very high level. They were mostly talking about the features of control rig rather than showing you how to do it. So I thought we could go from 0 to a fully functional rig in half an hour or so. This isn't a good rig. But for the kinds of animations I like, it's more than sufficient. I really enjoy it when characters interact with details of the scenery. I want my characters to pick up chopsticks or to actually grasp the sign in front of them or anything like that. It adds a lot of realism to a scene when your hands can be like this rather than a generic sort of any pose that they might, default to. It makes it so that it feels like your level is real. And while I'm not going to show you a rig capable of easily animating things like walk cycles or kung fu battles, I am going to show you how to get this kind of thing. And just so you can see, here's another example where she is holding a plastic statue and making a silly face. Same basic idea. All of this pose, including the silly statue, was built in this scene for this particular situation. It's a very nice way to do it, I say, and I think that the only real problem is that it's a little bit hard to get started. You have to know how to put together this rig. And even if you know how to do rigs in Blender or Maya, you might find that it's a little bit difficult to get it sorted here because the mechanics are a little bit different. So let's start with an empty rig and do this, right? In order to create a rig, you right-click on a skeletal mesh, go into Create, and down into Control Rig. If you don't see this option, make sure you turn Control Rig on in your Plugins menu. And then we're going to rename this to something like Live Tut Rig. And pop it open. Dun dun dun! You might have different tabs open when you first, create this. It's no big deal. Over here is our skeleton under the rig hierarchy. All the bones we have. Your bones might be different. I picked a skeleton that's not compatible with the default set of Unreal skeletons, specifically to show you how easy it is to set up a control rig for your specific needs. Here's where all of our code will go. But there's nothing here right now. It is a blank slate, and it is very nerve-wracking to be greeted with a blank slate. How do you even get started? Well, in this case, we're going to get started by right-clicking on a bone, and then going up to New and selecting New Control. Okay, what happened? It's hard to see that new control. It's inside of her body, and it's not on this list because it's down at the bottom. There it is. So when we told the bone to create a new control, it created a control named after itself and put it inside itself. So when we created the hips control bone, it created a hips control. It created a hips underscore CTRL control inside of the hips bone. This means that if the hips move, the control goes with them. Now we can't really see the control very well, so let's change the widget. This will allow us to customize the widget to look like whatever we want it to look like. It doesn't change the orientation or scale of the control, just lets us click on this widget and see what's up. And what's up is nothing. It's not doing anything. Why is that? Because we don't have any code. So let's put in some code. Boom. We'll want to set the hips bone to the transform of the hips control. There it is. And then execute. Pow. Perfect. Now it's all set up. See? Don't worry if you're moving these things. When you hit compile, they will go back to default. So you can feel free to experiment with exactly how this pose is set up anytime you'd like. Now you might notice that it isn't one-to-one. As we move this bone, it's actually only moving about halfway to where we might expect it to be. Now the reason for that is actually the opposite of what you might think. What's happening here is we are moving the control, but the control is inside of the bone. So if we were going to move the control 45 degrees, you can see how the control now looks like we've moved it 90 degrees. And that's because inside of the bone, it's at 40 degrees, but once the bone moves 40 degrees, the control has moved 80 degrees. Do you see that? This is one of the reasons why a lot of people don't like to put their controls inside of the skeleton. There are a couple of other good reasons to not put your controls inside of the skeleton. We're going to be putting all of our controls inside of the skeleton because the benefits for creating a fast skeleton, by that I mean something that we can create quickly, are enormous. Having all of our controls inside of the skeleton will allow us to do very, very easy things. And you're going to see that in just a couple of minutes here. I just wanted you to know that the reason this feels like it's not moving 100% is because it's actually moving 200%. The control is moving much faster than you think it should be. It's not that big a deal, though. Here, we're going to want to do the rest of these, right? How do we do the rest of these bones? Controls for all of these bones. Once we've selected them, we can go into New and add controls for selected. This pop-up menu says to press Alt to get more options. Oh, well. Here we have a couple of options. We can spawn them in as children, which is how we did it for the hips, as a hierarchy, which would just spawn them in the right place and in the right stack, but not as part of the skeleton, and as a list, where they'd just be a bunch of flat, standalone things. We're going to go ahead and put them in as children. And that means that we now have a bunch of these inside of the skeleton. Easy enough. We can just select them all and edit them all to be octagons. There we go. But they don't do anything. Why aren't they doing anything? Well, we didn't tell them to. Now, I've seen some tutorials that are like, hey, you should do this same thing for every single control. No, we're not going to do that. That would be terrible. We're going to brute force it. Now, brute forcing it is not the most effective way or efficient way to do this, but it has the advantage of working really, really easily. So that's what we're going to do. In order to brute force it, we need a list of every single bone in the body. One of the ways we can do that is by just using getChildren and pointing it at, say, the hips, and then getting the hips and all of the children's children. But we only want the bones. There we go. We now have this set of items that is every bone in the body. And here is a for each for you. And here's an error for you. So you can only run 64 nodes, which seems really low. I'm not sure that anybody could do a decent rig in 64 nodes. It's also something we can change. So we're just going to punch it up. However high we want to make it is fine. As I said, this isn't the most efficient or optimized rig. You're going to see a lot worse optimization in a second. But that's fine. We can always optimize it later. The most important thing for us now is to understand the basics of how a rig works, not to make the world's best rig. So we're going through every single bone in the body. And what we know is that if a bone has a control, it's going to be named the bone's name underscore CTRL. Well, here's the bone's name. That's right. We're going to do 100 string operations every frame. Obviously, this can be optimized later, but for now, it's the easiest way to explain how it works and to make it work quickly in terms of, getting it to run as soon as possible rather than as efficiently as possible. We are going to just see whether or not that control exists. Do we have a control named that? Branch. Here we go. So we're going to put these up here just for the sake of clarity. If that control exists, then we want to take that control's transform and use it to drive that bone. Perfect. Works fine. Obviously, you might think that you don't want these bones to work this way, and you can change how they work. These controls can be customized in a lot of different ways. No big deal. For now, however, this is good enough for our needs, right? And you might be thinking, is this really a good way to do it? To just brute force it through every single bone? Well, no, but it has a couple of incredible advantages, which I'll show you. What sort of advantages does it have? Well, let's go ahead and just select all the fingers and then create controls for all the fingers. Oh, look at that. There they are. And yes, they just already work. But you can't really see them working, so we're going to select them all. And what we're going to do is set them up to be a little bit more approachable. And is it this? Sorry, I can't remember which. There it is. So there we have it. We have a whole bunch of finger bones, and they're all controlled automatically by these new controls. Easy as pie, right? That's one of the main advantages of doing it this way. We don't have to manually tell the controls that they need to be attached to a specific finger. It's all automatic as long as we understand the naming conventions. Because the fingers are inside of the skeleton, they follow along whenever the skeleton moves. So we don't get finger controls floating in the air behind the skeleton. And we also don't have to worry about manually mapping those controls to each finger when the controls, when the hand moves. It's all automatic. This is the reason why I recommend living with the slight silliness that comes from having, controls inside of your skeleton. But, the power of a rig comes from not directly controlling individual bones, but from giving directives. We would like to tell the rig what to do and then have it just kind of do it without having to set every single bone. And what I mean by that is, of course, IK. So let's get started. We're going to go ahead and use a sequence node here. This just keeps our code nice and clean. And down here, we're going to use an IK node. We have a lot of IK options. Feel free to explore them. We're going to be going with basic IK today. We're going to select the right arm. And then we're going to select the right forearm. And then we're going to select the right hand. And then we're going to plug it in. Well, as you might expect, that's not right. There are a lot of reasons that's not right. One of the reasons is it doesn't know where it's trying to go. So let's create a control that tells it where to go. It's not going to be part of the skeleton. It's going to be separate, and we're going to call this right arm IK. You can name it something more technical if you like, but that's how I like to name them. Now, as I mentioned, if you move these things around, it's not permanent. So when we hit compile, it'll reset. See that? So if we want this to stay up near the hip, we're going to have to right-click on it, and tell it to stay there. Set offset transform from current. Now it will reset to that position. See? We're also going to need an elbow, a pole as they're called. Just move that back and out and save that position. Let's go ahead and customize this to be gray, just so that the animator knows that it's not something incredibly important. And let's set it up as just a vector, because this pole vector is just a vector. It's not a rotation or a scale. So we'll just make it a position rather than a Euler transform. And I'm only doing that to show you that you can. Once that's done, I can still move it, but I can't rotate it. I can't switch to the rotate widget or the scale widget. All I can do is move it. So let's get these things attached. The transform for the effector, there it is. And of course, the vector for the pole vector made into a location. But that's not right. Look at that damaged arm. Well, the problem with this is that the default axes are probably incorrect. They almost always are. But there's only 6 options for these axes. So, I mean, just sort of feel around for which axis works, and eventually you'll find one that seems closer to right. There we go. That seems closer to right. The hand is kind of pointed off in the middle of nowhere, so we're going to turn this into some kind of an orthogonal direction that doesn't suck quite so bad, and maybe move it so that it's not quite so floaty. It's just a default position. Now let's change the shape so that we can see where the hand is going to be pointing. That's not it. There we are. And now we have a fully functional set of IK for our right arm, and we can do whatever we want with it. Oh, and is that elbow a little bit high? Well, no big deal. Just move the elbow. You can see that animating is already starting to come together. We don't have to manually move every single bone of the arm. In fact, we could even use the roll bones in this if we felt like really showing off. But we would like to attach the left arm as well. So how do we do that? Well, we just go down here and we select these right arm IK elements and we duplicate them across. We rename right to left. And there we go. We now have the same elements on the other side. Similarly, we'll copy and paste, hook this up, and then mirror this. Once again, right to left. Now we flipped the wrong axis in this case, but that's not a big deal. We'll just manually fix it. And then here you can see that this is pointed the wrong way, so we're going to flip it 180, apply that. Then we're going to do this fun trick, flip it 180 again, and then use set shape from current. That way we're back to having a fully functional set of shapes in the correct sort of arrangement, and now we have full IK for both arms. Pretty easy, right? But I really don't like how our body works. I don't want to have to manually set every spine bone. I want to kind of be able to tilt the body arbitrarily. Now there's a lot of ways to do that, including other IK commands, but I really want to hammer home, this is IK, I really want to hammer home some fundamental concepts here. So one of the fundamental concepts I want to make sure you understand is the concept of a list or an array. There are so many ways to get arrays of bones, and those are things you're going to absolutely have to understand how to do. Because a big part of creating your personal rig is understanding which bones are going to be moved at the same time as which other bones and which need to have a bigger weight. So in this case, we are going to have a new control for moving the body itself around. And it's going to move all of the bones of the body at the same time. So that new control, we'll just create it. We'll call this body tilt. And we're going to move it up into the body somewhere, maybe here-ish. Save that position. And we'll just make this into something that we can live with. And we'll just move the shape up around the head, just for the sake of having it there. And we'll set that shape transform. There we go. Of course, it doesn't do anything at the moment, but it will in a second here. What it's going to do is alter these core bones along this line. So what we're going to do that is we're going to need a list of those core bones. One of the ways you can do that is by getting an item chain. If we specify to start at the hips and then go all the way to the head, then the item chain will get us hips, spine, spine 1, spine 2, neck, and head. Then we can just do a for each. And we can set each of them as we see fit. We could, in fact, pass that to one of the more robust IKs that takes in an array. But in this case, we want to do it ourselves because I want to teach you about parenting and weighting. So there are a lot of constraint methods, and parent constraint is probably one of the most generic and basic. In this case, we're going to be taking the bone in question and editing it. Here it is. And the parent that we're going to be using is our newest control, body tilt. Oh, look. So it is currently set at a weight of 1, which means that all of the bones are set to exactly match the motion of this control. That includes the hips, which are one of the core bones. So that's why it looks like she's just moving around like a log. And that's true of rotation and scaling and transforms, all this stuff, right? We really don't want this to have a weight of 1 for all bones, but you see, there's this thing called ratio, where it's 0 at the first element and 1 at the last element. And we can just plug that into the main weight, and there we are. We already have something that is no longer being silly. The hips have a weight of 0, so they are not affected at all. And the rest of the body has a weight that increases rather rapidly. There's a lot of ways to handle this. In this case, we're just going to divide it by 2 so that we have a little bit less suddenness. Now you can really see that there is something wrong with the head. You see how the head is stretched out, looking kind of weird, and the neck's all busted up? That's because we are currently constraining on all of the various possible parameters. That includes translation and scaling and all sorts of stuff that we don't care about. All we really want to do is use the rotation. We don't care about the translation or the scaling for this. We just want to rotate stuff. And now that we're rotating stuff, it's much more natural. And feel that? That's a pretty good way to set it up. You can work with that, right? Pretty basic. There are, however, some issues here that are important to understand. One of these issues is order of operations. And order of operations is one of the most critical things you're going to have to understand here in Control Rig in Unreal, because this is something that will bite you almost all of the time. And you have to understand what needs to happen first and what needs to happen next. You see how our hands are no longer actually attached here? What's up with that? Well, that's because we attach the hands first and then we move the body. So the hands are all fixed at a specific set of angles. And then when we move the body, they deviate away from where they're trying to grip. Similarly, if we wanted to try and move the head directly using this direct control bone, it's not going to get very good results. It's not too shabby, but it's not perfect. And the reason for that is because this core spinal manipulation actually needs to happen first, rather than last. Now, no matter what we do with the spine, the hands will try to, that's not the spine, the hands will try to stay attached to their target. Now they might not succeed if the target gets too far away, but they're never going to just randomly wander off. Similarly, when we change these direct controls, they're going to have 100% effect rather than a muted effect, because this is being applied first. Because all of our controls are inside of our skeleton, when we move the skeleton here, we also move the controls, which means that the controls effect is going to be completely intact. Don't worry if you didn't understand that. It'll make sense after you try it a couple of times and realize what's going on. The basic idea here is if your order of operations are wrong, you're going to end up moving things away from where you intended them to be, because you have to do it in a different order than you thought you did. That's something that's going to come up a lot, and all you have to do is keep on top of it. Believe it or not, this is all you need. This and the understanding of how to aim at something is really all you need in order to create a fully functional set of controls. So we can actually add this to the scene. There it is. Once you add it to the scene, it will automatically be added to whatever level sequence is in the scene. Our level sequence is a little bit busy, but that's okay. We'll go ahead and turn on automatic keying and create a starting position here. And we can just have her do something goofy. Why not? We'll have her bend in a funny way. And maybe she'll put her arm in a funny position here. Perfect, right? And then, of course, if we wanted to, I'm not going to teach you how to use the sequencer in any great detail, but I do want to just set this up so you can see how easy it is to make it work. And all we need to do is, change something in the middle. And now we have an animation, and it's already running. Obviously, the animation is spectacularly bad, but that's fine. I didn't actually try. So that is the extent of it. You can create your own animations that easily. In order to take this rig to something fully usable, all you have to do is the same thing we just did. You have to do IK for the legs. You have to choose which clusters of bones you want to manipulate on the face, using what controls. It's not complicated. It's just a matter of figuring out what you want and making sure that you're doing it in the right order. If we were to take a look at the existing rig that I created, which is here, this is it. So this is almost the exact same setup. See? This is even the same terminology, more or less. Spine, direct control, IK. And here's direct control, spine. They're in the reverse order, but that's fine. And IK. The only difference is I've got this set of facial expressions. The facial expressions are just these bones that allow me to change the specific expressions on the face. There are a lot of bones on the face, and it would be very difficult to actually edit them all individually. So I've set them up in groups, and then I edit them all from a central controller. So for example, for the lips over there, I've got the left up lip and the right up lip, and the up lip itself twice because I wanted it to have a specific weight. And the result is that that control is applied to this set. As I said, you need to know how to create sets of bones. I've chosen to make the upper lip's bones all attached to one constraint. You don't have to. You can set it up any way you want. But there's nothing special about this. This is something that you can do. You've already seen how to do it. It's the exact same way we set up this spinal manipulation. And I just did that for a lot of these. Some of them are just a single bone, like the eyelids are just one bone. And those are just direct controls. We don't have to actually specify them. But, it's just a matter of figuring out what you want. I've added in single bone controls for rolling so that we can roll if we need to move our hands in funny ways. There's a lot of things that I've added in here that, I thought about. I was like, do I want this? Do I want that? How do I want to do this? And none of this involved advanced anything. There's no physics. There's no complicated mathematical heuristics. I just decided which bones should be manipulated according to what sort of groupings. And that's all. I took away most of the direct control bones because I felt that this was good enough. Being able to control our character via these, directions like this was good enough. I didn't need to do it, direct control bones for most of these bones. And of course, I set up leg IK. It's the same thing. The only thing this does that I didn't cover is down here. This is the eyes. All I do is I use this animate command to aim the eyes at the eye target. First the left eye, then the right eye. The eye target is this red thing. And I just do that so that Kate can look around some. So for example, if I were to move it over here, you can see that Kate is now looking over towards that. See? That's all. It's just a matter of figuring out how you want to animate things and clustering it. And that's something that comes with practice. I'm not going to claim that I have set this up right or correctly, but I've set it up well enough for me to use it to develop my stuff, and that's all that matters at this point. I'm not trying to do this professionally, and if I was, I guarantee you I wouldn't be setting it up with string operations 90 times every frame. I would set that up a little bit more hard-codedly, and that's something you can do. All of these things can be optimized. You can optimize the hell out of all of these applications without actually changing any of the underlying way that these things get animated. So if you create an animation that uses this head joint, and then you later decide to change exactly how this head joint connects to the various bones it connects to, that's fine, because it's the head joint itself that is being animated. The bones are following along via code. So if you change the code, it's fine as long as the result is the same. So if you end up changing over to a hard-coded method that's more optimized, that's fine. You're not even going to notice the change. There are a lot of things that I haven't covered. I didn't tell you how to do physics. I didn't tell you how to do reverse setups so that you can bake an animation to the control rig. I didn't tell you how to track a specific world coordinate, which is not the same as a global coordinate. There are a lot of things I didn't tell you here. But I just wanted to get you started, because once you understand enough to start, then when you look up more solutions, you'll be able to figure out how to apply that to what you need. Once you're, here, once you're doing this, and you're building this kind of animation, and you're like, okay, well, I actually need her ponytail to bounce, or whatever. That's something you can look up and add into it, and it will flow very naturally. Whereas, how do I get started in the first place? A little bit more difficult of a question. So this is just intended to tell you how to get started in the first place. If you've seen any tutorial videos that cover the same thing, especially if they're better than mine, let me know. I literally couldn't find any that started from scratch like this. It was just not possible to search for them. I don't know. Maybe they exist somewhere and my Google foo is bad. Either way, I hope that you'll try it out. I hope you'll have some fun, and maybe we'll see you around.